welcome. Today we'll talk about 2.8 and 3.3, how to graph linear inequalities and absolute value inequalities, as well as system of inequalities. Please sit back, follow along in your notes. You have this right here with you. This is day 1 of this chain not being with you. We've already talked on 3.1 and 3.2 about solving linear systems, but now it's going to get a little more complicated. I hope you enjoy. Follow along, please. All right, 2.8, 3.3, aim how to use graph linear inequalities, absolute value inequalities, and system of inequalities. Ooh, a little bit more exciting. For this lesson, I'm also going to use a lot of different color pens. How exciting, to keep it kind of exciting and fun. So please follow along. If you have some, you can also follow along with different color pens and pencils. Part 1, spotty dotty, solid lines. You remember this, guys? Spotty dotty, we like to potty. We did that with maybe number lines. We had dotted lines versus open circles versus closed circles. We're also going to use solid lines. Solid as a rock, okay, depending on which inequality we are given. If you have less than or greater than, you're going to use dotted lines, just like an open circle, right? It's kind of similar to an open circle and a number line. Do you remember this, you guys? If it's not equal to 2, but it's everything greater, remember how we did this? And also, less than or equal to or greater than or equal to if it's a solid line, because it would mean it's a closed circle, okay? Right? If you have a number line, it could mean that it's less than or equal to 2, right? So just keep those guys in mind. All right, so let's just try these 2 examples, all right? We're going to try these examples. Example 1 is graph. Now, we don't just have 1 to graph, we have 2. And just keep in mind also that x equals -3 and y equals 2, what kind of lines you should expect from them, all right? And these aren't inequalities, these are equalities. So let's graph them together, all right? So we have x equals -3, so I'm going to go x equals -3, put a dot there, and I'm going to draw a vertical line. Okay, everyone here are expected to know that x equals -3 should produce a vertical line. Y equals 2, okay, I'm going to go fun and use a different color. Y equals 2 is here, that means it's a horizontal line. Another thing you should do is always label your equations or your graphs. X equals -3. All right, and we're done. There's nothing to it. But there's something we haven't done. Here it is, right? Solving linear system means, because this is a linear system, isn't it? Is that we're trying to find the point of intersection. And the solution, the only solution, really, right? Oh, sorry, I drew dotted lines, huh? I meant solid lines. Solid as a rock. Because it's actually equal to them, all right? Solution would be -3, 2. Only one solution, right? Okay, so let's go to the next side here. Next side says x is greater than -3, y is less than 4, which means they are both dotted, right? So we should mark that, just in case we forget during our process. And I'm also going to use different color markers for this. So x is greater than -3. So -3 is here. And I'm going to draw that dotted line. I'm just trying to put an emphasis on the importance. But it says here that it's greater than -3. So you guys, greater than -3, it means everything here, doesn't it? -2 is greater than -3. -2.9 is greater than 3. 0 is greater than -3. 1 is greater than -3. So I'm going to go like this. But I'm going to do it very systematically. And I'm going to also write draw pretty lines and very clean lines. Let's do the next one. It says y is less than 4. So y is less than 4. I'm going to draw that dotted line. It's a horizontal. So make sure you write y is less than 4 here. And I'm also going to label this one x is greater than -3. But it says less than -4. Less than -4. Which implies that I'm going to draw shade in only below 4. We all know what less than 4 means. That means it's everything below 4, right? Because 5, 6, 7 is all greater than 4. But one thing you have to make sure that you do is this. Where is the solution? It's not just a point. It's a whole region, right? Where is the region? Where it's double shaded. It's here, right, guys? Everything greater than -3, but less than 4. So I'm going to darken that area. And all that is solutions. Think about how many solutions there are. You're right. There are so many solutions, like so many. But just remember that the solutions along the dotted line are not solutions, but everything below is a solution. So if I were to ask you, give me a solution, you could name me any point here. How about 0, 0? And you would say, yes, it's a solution. How about 0, 2? Yes, it's a solution. You should be able to tell me all the solutions that are possible. How about negative 4, 0, you say? And you would say, oh, no way, because it only satisfies one of the inequalities. All right, so part 2 now. Can you guys take a look at part 2? So turn the page. What is the solution of an inequality? Think and look. So we're going to see, by given points here, we're going to see who it belongs to. Like 0, negative 2, negative 15, 15, negative 2, negative 5. Which of these guys does it belong to? Okay? So the first thing we should do is we should take a look. I know that your shading doesn't show up, so can you guys make sure that you shade that in? And also, what we should do is, it's hard to tell, foresee what is, beyond what you see. So what we're going to do is write the equations for all of these. So I have the equations for you. So writing inequalities, right? So it's just like a linear equation, really, right? Except we have inequalities involved, so we're going to need less than or greater than those symbols. Slope and the y-intercept, so you should always identify your y-intercept and slope, y-intercept and slope, y-intercept and slope. Write those down. And here's what I was able to come up with. See if you can match mine. Y is less than or equal to negative x plus 2. Y-intercept is at 2 and slope is negative 1. Also, this one here, y is less than, right? Because it's less than this guy. So English Fisher, it's less than or equal to. And the slope here, I counted as 3 over 2. And y-intercept is negative 1. Here, you know for sure it's going to be a negative slope, and you know it's going to be greater because it's above this y value. Every y value, if you were to point here, it's pointing to something greater. Along this dotted line, any y value, everything shaded is greater than that value. So y is greater than, slope I counted as negative 1/3 x minus 2, because that's the y-intercept. Okay? Now let's check 0, negative 2. 0, negative, sometimes it's going to be easy to tell whether there's solutions or not. 0, negative 2, 0, negative 2, definitely solution of BTS. Let's go to this guy. 0, negative 2, for sure, PP, AP. 0, negative 2, oh! For XO though, it's along the dotted line, so you say no. Does not belong to XO. Do you see how we're playing this game? Alright? How about 4, negative 1? 4, negative 1. Let's go 4, 2, 3, 4, negative 1. Nope, doesn't belong to BTS, right? How about this guy? 4, negative 1, of course, PP, AP. 4, negative 1, all the way here, and then XO, yes, it's going to. But we don't need to finish this one, because you know that this line is going to go on forever this way. So we know for sure it belongs to XO. Do you see how we're doing this? All right, how about 2, 0, 2, 0, 2, 0? Now, 2, 0 here, it belongs to BTS because it lies along the line, and it's a solid line. 2, 0 here, definitely, right? PP, AP. Also, how about XO? 2, 0, definitely, because you know that's everything beyond this line. So this one belongs to all of them. Now, what about the cases that it's hard for us to see? For example, here, let's try this guy. Try all of these, you guys, with your friends next to you. Negative 6, 0. Well, let's say you say, well, negative 6, 0 for sure it's going to belong to BTS, for sure, okay? PP, AP, negative 6, 0, you know it's not going to belong to him because he's like already not shaded here. Negative 6, 0. How about this guy? We're like, XO, he's the question, right? So let's try it. And what do? We plug this value into our inequality and check. So let's do that right now, okay? So we're going to go y is greater than negative 1/3 x minus 2. Does it work if we plug in negative 6, 0? So 0, is it greater than negative 1/3 x is negative 6 minus 2? Is that true? So let's do our math. 0 is greater than, this guy's going to give us 2 minus 2. You guys, is 0 greater than 0? Is 0 greater than 0? Tell each other the answer. Hells no! So you say does not belong to XO. This is false. You guys, don't deny the truth. 0 is not greater than 0. 0 is actually equal to 0. That means it's not going to work. So this guy only falls in for BTS. It only belongs to BTS. So you guys try the rest of the values, all right? So try to ask each other for help, and sorry I can't be here. All right, next what you're going to do is this, you guys. You're going to actually watch the keynote. Go on Schoology and do part 3 with the keynote. The keynote 2 pages, 12 slides are attached to your worksheets as well, all right? Good luck. Welcome back, everyone. So, you've already watched the Schoology keynote for basic lessons on this, but I'd like to go over with you how to graph together. So part 4 is all about graphing to solve absolute value inequalities. But remember, if we're solving absolute value inequalities, it means we're trying to solve a value or a solution set, right? So it could be more than one value. So there are some examples that are already on the video that you're going to watch, but I'm going to do a few of them that you will not see. So I'm going to go down to number 2. All right? It says solve. That means we have a system of linear inequalities, but also including an absolute value. So we're going to graph all those and see where the solution lies. And I'm going to use 2 different colored markers. So let's start with this one. This one's dotted, right? So spotted dotty, spotty dotty here as well. Spotty dotty, if you don't know, look it up, okay? It's like a cute little character with dots. So this guy says, you guys, it's the same shit as a linear equation. Who's your boyfriend? Who's your man? Boyfriend is -1, and your slope is +1/1. So let's go there and graph. -1, up 1, right 1, 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 down 1, left 1, down 1, left 1, down 1, left. Okay, got the point? Now you draw some dotted lines here. Okay, and I'm going to write that here. And you guys, it says here, it's less than. So think about all the y values along this dotted line. It's everything less than. So you know it's going to be shaded below. Do it neatly, all right? Everything below, but not including anything on this line. Now, for the absolute value, you guys, let's start with your Hong Kong, always. Your Hong Kong is going to be 2, +1. So let's start there. But I'm going to use black marker. 2, 1. 2, 1. Oh, so it ends up in the same place, huh? But it says here, go down 1. So remember, it's absolute value, so symmetric. Down 1, right? It's going to be a mountain, isn't it? You should know what to expect. Down 1, right? Down 1. Okay, it's symmetric completely. Symmetric. And you guys, it's dotted. Dotted, 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 dotted. Okay? So we got that. And this guy is going to be y is greater than -1/2 x absolute value of x minus 2 plus 1. Always label. But it says here that we have to, it says here, it's everything greater than. So it's everything greater than. That means it's above this guy, right? So we're gonna shade that in. Above, above, above. Everything above it. But remember how we're trying to find the solution, you guys? We're trying to find the solution. That means where is the solution where they both intersect? And you can see right away that it's above this this mountain, and everything below this blue line from this first inequality. Therefore, it's everything here. So I'm going to darken that area where they intersect. Okay? Do you see that? All right? That's the area. And that's our solution. That's our solution. Okay? So it's like a solution set, not just one solution. We're going to do one more example. Okay? You can also watch the other video for more examples. Don't worry. I won't let you alone. Okay? So guys, let's do example 5 together. Okay? Now what we're going to do is this, part 5. Writing inequalities of graph. So you're going to go backwards now. So you see an absolute value inequality, right? And you see where it's shaded. Okay? So I know a lot of you guys are already saying, oh yeah, that's greater, because it's greater than 0 here. And that's why you're in a good roll. So you guys, isn't this also a solid as a rock? Okay? So just write that out so you know it's solid. Okay? So you know it's going to be either this or this. Okay? All right. So let's actually start with the vertex. HK, your Hong Kong. What is your vertex? You're right. I heard you. -3, 0. Okay? And you guys, let's do our A. You know how we have our inequality? Y equals A. X minus H plus K. But remember, this guy's going to change, right? Because it's an inequality. All right. So now, what is our A? Our A looks like it's up 1, right 1, up 1, right 1. So it's just 1. So let's write the inequality. Y, we'll leave this plate blank, so just in case. And it's 1. We don't have to write that 1. X plus 3. And then we're done. But it's going to be solid, so you know it's going to be one of these, but it's greater than 0. Think about every coordinate along this. -2, 0. -2, 1. Isn't it greater than 1? So it's going to be y is greater than or equal to. So here's our inequality, all right? And I think I went over this in the other video as well, so make sure you guys guys check those. And as long as keep going on your notes with part 6 with the word problems. Good luck. Bye.